All right, so like we do with all functions, right? Once we kind of get the basic shape, what we can do is transform it and go from that. So we're going to basically practice that skill yet again. So we'll find out what the basic function is, identify the transformations, sketch our new graph, and then be able to ask domain and range questions, particularly the domain. The range is everything, so we expect it to still be everything, but the domain may definitely flip around. So when I look at this next function, right, if you took away the +1 and the -2, what's left is log base 3 of x. All right, so our basic function here is log base 3 of x. So even if you wanted to graph it, right, we know for sure it goes through 1, 0. When x is 3, the y value is 1. When x is 9, it's 2. So we even have some points, some data points that I can plot. So there's the basic function, log base 3 of x, doing its basic shape that we have basically learning so far. What's the transformations? Well, I can see we're subtracting 2 from x, so there's basically going to be a move to the right 2 units, and then this +1 is not in fact impacting the x, it's impacting the whole function. So it's going to be a movement up, right, by 1. And so basically transforming graphs, let me go ahead and use a different color. If I take this point, it's going to move over to the right 2, right, and then up 1. This point is going to move to the right 2 and up 1. This point is going to move to the right 2 and then up 1, right? This point here would move to the right 2 and then up 1. The vertical, since we're moving over to the right 2, that means my vertical asymptote, right, is also going to move, and it's now going to be the line x equals -2. So sketching that, I think what we end up with is that curve right there. All right, so what I have in red, it's basically the sketch of that dashed black line shifted over twice and moved up once. And then definitely the vertical asymptote will shift over twice as well. So what's this defined for? Well, it starts at at +2 and beyond. So the new domain is from 2 to infinity. That makes sure if I give it something that's past 2, that guarantees that this will be positive, and we know that the logarithm has to stay positive. All right, so if I try putting 0 in there, we get -2. No good, right? But if I shift everything over, starting at 2, everything is good. So there's basically our basic function, the transformations, right? What our graph looks like, and then based off of that graph domain. Of course, the range is still everything. It was everything to begin with. It's still going to be everything to end with, right? Because we have a function that's strong. So what about this next function? Well, we're talking about log base 4 of x, and it's being subtracted. Well, if I rewrite this, this is negative log base 4 of x plus 3. That might be a better way to look at this thing. So what's the basic function? Well, it's log base 4 of x. What does that look like? Well, it's going through 1, 0. It's going through 4, 1. And it's basically looking like that snapshot right there. All right, so there is what a log base 4 of x graph looks like. What are the transformations? Well, there's nothing happening to the x, so we're not moving it left or right, so no horizontal transformations, but this negative is impacting the logarithmic function. So this means that there's a reflection through the x-axis, right? So this is basically flip-flopping through the x-axis. The +3 is also impacting all this, so we're going to basically be moving up 3. Order of operations, say we do multiplication before addition. So the first thing that's going to happen, let me try changing some colors here, right? The first thing that's going to happen is everything's going to flip, right? So all this action is going to flip, all right, through the x-axis. So I've got that. Then all this action is going to be shifted up 3. So this point, 1, 2, 3. This point right here, 1, 2, 3. And so the graph is basically going to look like this guy right there. It will eventually cross the x-axis, right, because it under normal circumstances is going to positive infinity, but here it'll be going to negative infinity really slowly and positive infinity really fast. So there's a quick sketch. I even have a couple of data points that are that are roughly on it. So the point 1,3 is on it, and it looks like the point 4,2 is on it. Okay, so we've got those 2 points. The asymptote hasn't changed, so that means the domain is still from 0 to infinity, and the range is still negative infinity to infinity, because that's what it was to begin with. Since I didn't move the vertical asymptote around, then the domain didn't change as well. So what I have in red is a really quick sketch of what 3 minus log base 4 of x looks like based off of the basic function and the transformations that are occurring around it. The next one, we actually can use a calculator because the natural log function is on the calculator. All right, so we'll check our work with that. But right now, the basic function that I have is the natural log of x. The natural log of x, again, like all functions, logarithm ones, goes through 1, 0, slowly goes up in this direction, and goes to negative infinity in that direction. So there's our natural log of x function. What are the transformations? Well, we're adding 4 to the x, so that means we're moving to the left 4, including our VA, right? So be careful there. The plus 5 means we're actually moving up 5. So my new graph, the vertical asymptote used to be the y-axis, it's moving to the left 4. So now, right, my vertical asymptote is y equals negative 4. This point is moving back 4, 1, 2, 3, 4, but it's moving up 5, 1, 2, 3, 4, 5. All right, and so all the behavior is basically going to be doing this right there. I don't need anything else, just follow the motion. So that data point moves back 4 and up 5. Vertical asymptote, right, it's going to have that behavior here, and then we're going to slowly go to infinity in that direction there. So there's basically what that graph looks like. In terms of its domain, since the shift, it's defined from negative 4 to infinity, and the range is negative infinity to infinity. All right, so there's the basic shape. Fortunately, the natural log function is on my calculator, so let's verify this, right? Let's go to, let me turn my calculator on. Let me get that glare out of there. And so we're going to go to y equals, and we're going to graph the natural log of x plus 4, right, and then plus 5. All right, and let me go ahead and do that on our standard viewing rectangle. I think I messed around with it last time. And so what we see is we basically have that graph there. Now something odd also occurred here. You'll notice that the calculator isn't going down to negative infinity. That's a machine error right there. We know that the graph should be going down there, but the numbers are getting so small that the graphing calculator is having a tough time doing that. So there's your little ding towards technology. For as great as technology is, right, it does have its shortcomings, but you do notice, right, that this point here moved over 1, 2, 3, 4, and then up 1, 2, 3, 4, 5. So it basically is in the same area that I expected, and 1, 2, 3, 4, right, x equals negative 4 is serving as that asymptote. Perhaps I've zoomed out too far. Let's help the calculator out here. If I go to the window and maybe make this negative 6 to 6, right, maybe that'll help the graphing calculator show that asymptote a little bit behavior. And you see that it still is having some problems, right? This is occurring at negative 4, right? But it is going down towards negative infinity. So again, our algebra knowledge is probably better than the calculator, even though it's giving us a good indication that we are right in terms of graphing it. So there's what the graph actually looks like, right? With it's the natural log function with its basic character moved back 4 and up 5. And there's what the technology is doing with it. So be careful with technology. For as great as it is, you still got to know what you're doing so you have a better graph actually in this case. All right, so there's kind of hopefully some good review. Our only thing that's changed here is our basic function is new. It has some new characteristics. The transformation idea is the same. We move left, we move right, we shift up, we shift down, we reflect, all that good stuff. Alrighty, so let's go on to some new stuff. We'll kind of use the fact, one thing that we haven't used so far is that we're talking about inverses. Well, we have and we haven't, but we're really going to do that in our next video. That'll come soon in a moment.